Hi everyone, welcome to Dr.Peiris classroom. So this is the digital logic design course and today's lecture is about the Boolean expressions. So in today's lecture first I will show you the three basic logic gates and the corresponding truth tables and the Boolean expression. Then we will see how to obtain the Boolean expressions using the logic diagrams. So what are the three basic logic gates? The inverter, the and the OR gate. So here is the gate symbol for these three gates. So this is the gate symbol. So this is what you will see in a circuit diagram for the inverter. So what happened in the inverter? So if you give an input A, the output would be the complement of A. So the complement is written as A prime. So which means by looking at the truth table you can see, so this column corresponds to the input and this is the output Y. So if your input is 0, the output becomes 1. If the input is 1, the output is 0. So basically what happened in the inverter, it switched the input. So the logic 0 becomes logic 1 and the logic 1 becomes logic 0. So it switched the inputs. And for the inverter there is only one input. But for the AND gate and the OR gate there are two inputs. So the two inputs are written as A and B. Here also the same thing, two inputs are A and B. Now let's look at the AND gate. This is the logic symbol for the AND gate and the output is written as A and B. So for the AND operator we use the dot as shown over here. So sometimes to make it simple we omit the dot. So simply you can do AB, which means there is an AND operator in between the two input variables. Now if you look at the truth table, so since there are two inputs, we're going to have four different combinations for the inputs. So the inputs could be 0 0, 0 1, 1 0 and 1 1. So when there are two inputs, 2 to the second power, we gives the number of different combinations, so which is going to be 4 different combinations. So if you look at the output column for the AND gate, so when you see a logic 1 for the output, only if both inputs A and B are equal to 1. If both inputs A and B are equal to 1, the output would equal to 1. And the next one is the OR gate. This is the logic symbol. So for the OR gate, the expression is Y equals AOB. The operator O is written using the plus, but this is not arithmetic plus. This is the logical O between the variables A and B. So the plus sign represents the O and the dot represents the AND. Now it's the same for number of different combinations. So it's going to be 0 0 0 1 1 0 and 1 1. So if you look at the output column for the OR gate, so if one input is 1, the output is 1. So that's the difference between the AND and the OR gate. So for the AND gate, both inputs need to be 1 for the output to be 1. But for the OR gate, if one input is 1, the output is 1. So that is easy to remember. Now let's see how do we obtain Boolean expressions for the given circuit. So we basically going to obtain the output expression for the F. So to do that we need to remember the Boolean expressions for the three gates that we discussed. So for the inverter it becomes the complement of the input. For the AND it's A dot B, or simply we can omit the dot. For the O we do A plus B, so plus represent the O. Now let's see this one. So we're going to write the expression for the output F. So we need to understand what are the gates we have and how many inputs in here. So if you look at the diagram, we have only two inputs A and B and the output is F. So this is an AND gate. So if it is an AND gate, what would be the output of that one? So what is connected to the AND gate? So the inputs are A and B connected to the AND gate, which means the output of the AND gate should be A, B. And now this is an inverter. So the input is connected to the A. So the output of the inverter should be A prime because the input is A. Now these two inputs are connected to the OR gate. So for the OR gate, the inputs are A, B and A prime. So we're going to combine these two terms with the O operator. So the O operator is the plus A, B, O, A prime. So this is the Boolean expression for the output F. Now let's see another one. So the same thing that we're going to do, we're going to follow each and every gate and then write the output for each gate, and then at the end we will obtain the expression for the output F. So again we have first, this is an AND gate, it is connected to A and B inputs, so which means this is going to be A, B. Now this is an inverter which is connected to B, so which means this is B prime. And the next one, this is an AND gate, so what is connected to AND gate? B prime, and this is connected to A, so this is basically A. So A and B prime connected to the AND gate, so it is written as AB prime because it is the AND gate. Now at the end we have an OR gate, so what goes to the OR gate? AB and AB prime. So this is AB or AB prime. So this is the final expression for the output F. The next one, so again one at a time, one gate at a time, and be careful what are the inputs connected to each gate. So the first one, again AND gate connected to A and B inputs, so this stays as AB, and this is an inverter connected to B, so this is B prime. Now you see in this question we have three inputs A, B, C. So what goes to here? C and B prime, and this is an OR gate, so which means this becomes B prime or C. Now at the end again we have an OR gate, so what goes to the OR gate? A, B and B prime or C. So be careful when you do this because this is a single term, so if you want you can put a parenthesis. So this is A, B and O, B prime or C. So in this case we don't need the parenthesis because it is the O between each and every term, so you can get rid of the parenthesis because we are doing the O operation between both terms A, B and B prime or C. So this is the final expression for the output F. Now let's see this one. So this has 4 gates altogether, and you see that this AND gate is a 3 input gate as well as this OR gate is a 3 input OR gate, but we do the same exact operator between the inputs. So if I have this AND gate which has A, B, C inputs, so what would be the output? A, B, C. So it is A and B and C. And now this is the inverter which is connected to C, which means it is going to be C prime. Now here is the O, what is connected to O? So this line is connected to B, this is connected to B, and this input is connected to A. So which means this output is AOB. And so what is the output of this OR gate? This OR gate, what is the output? So ABC, C prime and AOB are the inputs. So we can write it as ABC O, C prime O, AOB. So these are the 3 terms goes to the input terminals. A, B, C go on the top one, C prime goes on the second one, and AOB goes to the third input. And this is the second output, actually this is G. So there are 2 outputs in this example. So the G output is equal to what? It is connected to this OR gate, so the G output is basically A or B. A or B. So this is how you simply obtain the Boolean expressions using the given logic diagrams. Very simple. Follow one gate at a time and write the output expression for each gate, and then see what are the inputs. When you find the output expression, make sure you understand what are the inputs in each gate. And the next one, so this one has 4 input variables, A, B, C, D. So 4 input variables. So now let's do one at a time. So what are the gates that we have here? So the first one is an OR gate. This is an OR gate. The inputs are A and B. So we can do this as A or B. And this is the second one. So this is connected to C. This is an inverter. So the output is C prime. Now what goes into this OR gate? C prime and D. So this is C prime or D. Now next we have the AND gate. So what are the inputs of the AND gate? A or B and C prime or D. So you have to be very careful when you do the output for this gate, because we are doing the AND operation between A or B. So we need to do the AND operation between A or B and C prime or D. So you definitely need the parentheses, otherwise it is going to be wrong, because you will miss the AND operation between these two terms, because the entire input goes to this gate is A or B as well as the C prime or D. So you need to put the parentheses, which basically denote that there is an AND operator here. So that AND, the dot represent the AND. So make sure you put the parentheses. Now what happened to this output? So this final F is basically going to be the inversion of this output from this AND gate, because there is an invert. So this entire thing becomes the complement. So how do we write the final output F? So we have A or B term and then C prime or D term. Now this entire thing need to be the complement, or you take the inversion of that. So this is the final answer for this output F. So that's all for this lecture. This is a very short lecture about how to obtain the Boolean expressions from the circuit diagrams. So please subscribe to my YouTube channel. You can find more videos of this class as well as for the other classes. And don't forget to visit my website drpeirisclassroom.com. So in my website I have gathered all the videos under each course, so it is very easy for you to find out what topics are covered, and it is easy for you to see all the videos at one place. So thanks for watching everyone. I'll see you again with another video. Bye.